Welcome to the Stormsurf Video Surf Forecast of the week starting Sunday, November 29th. Looking at significant wave heights for the North Pacific Ocean, we see an improved pattern setting up. First off, remnants of a gale off the Pacific Northwest, barely 17-foot seas, maybe 18-foot seas, of no particular interest. A stronger system just south of the Aleutians in the northern dateline region with 31-foot seas, and this is just the start of a string of multiple systems forecast to traverse the North Pacific and generate much swell for Hawaii and the U.S. West Coast. It finally looks like our El Nino pattern is starting to set up in earnest. As usual, we'll start our tour looking at jet stream level winds. These winds help support the formation of storms, and when those storms do form, help direct their path. We have a healthy jet stream flow finally taking over the North Pacific. As you can see, winds pushing off Japan, not particularly strong in the 140 knot range, but basically running flat west to east, making it to a point north of Hawaii before they split, and actually even further than that, almost to about 135. The real split starts somewhere in here. We got a little bit of a trough, so it is troughs that help support the formation of gales. That is a dip in the jet stream that supports a counterclockwise flow aloft and also down at the surface, and that means low pressure. And as we saw, there are some seas in this area associated with this trough or low pressure here, but nothing of particular interest. And then notice this split here sends the northern branch of the jet up into Canada, southern branch down into Baja, providing high pressure right here, nice light winds, and beautiful conditions. And as today, as you saw if you were in central North California, good, solid 10-foot phase surf, clean conditions. The winter looks like it has truly begun. Hawaii also getting solid swell as well. So things are looking up. Let's put this in motion. As you see, the jet, now here's what things get interesting. This trough starts digging out. A new trough, typical of El Nino, starts digging out in the western Gulf, in the central Gulf of Alaska. Winds start building here. Get a nice, not a over-the-top flow, but 160 knot flow. That should definitely help more gale formation come Tuesday in the Gulf of Alaska. And notice the split point just barely hanging here off California. High pressure trying to hold it together, but at some point it will collapse. The jet will come in, and then massive weather will move into the U.S. West Coast, but not right now. The trough continues Wednesday, Gulf of Alaska, new trough setting up over Kamchatka. Roll this out. The Gulf trough continues, builds over the dateline with another trough on Thursday. Good solid wind supporting it. Now here's where things get really interesting, as if this isn't good enough. Notice winds building to 100 knots pushing off Japan, and watch this baby just blow up here. You get 190 knot winds pushing over into the western Gulf of Alaska by almost Sunday. Bit of a trough trying to get organized here, and we'll just roll this right on out to 180 hours, and there you go. You couldn't have a much healthier jet stream flow than that. 170, 180, 190 knot winds, consolidated running from Japan into the Gulf of Alaska. This is the hallmark of El Nino, and it looks, if one is to believe the models 180 hours out, that El Nino will finally express itself in the atmosphere. We've been waiting for 2 months for this to happen. It's a slow developing El Nino that speaks to its character, but all the warm water, and we'll get into that in a minute, that has been gurgling up off the Galapagos is finally starting to have an impact on the atmosphere, and the inactive phase of the Mjo is finally fading out, so now El Nino gets to do its thing. Next, surface level pressure, surface level winds. As we can see, and as expected, a little bit of low pressure residing here off the Pacific Northwest. No real winds of interest, and we're going to ignore that because we have a much larger fetch, 40 knot west winds, just shy of the Aleutians here, actually a bit further south than that, almost in the sweet spot relative to both Hawaii and the U.S. West Coast. Certainly getting traction on the ocean surface, generating seas, mainly aimed to the east at the U.S. West Coast. Hawaii is down here. The Great Circle tracks go sort of like that, so these are kind of perpendicular. We'll get into that in the wave model portion. Anyway, roll this out. The system sort of fades a little bit as we get into Monday and Tuesday. 30-knot winds, not so interesting. Tries to rebuild a little bit here. Tuesday, get some additional fetch, and also notice a new system developing off Kamchatka on Tuesday night. Still, look at this. This is great. We got fetch here. We got a new developing fetch here. This is and we got high pressure just north of Hawaii helping to protect it, and a little bit of high pressure off the U.S. West Coast. You can't ask for a much better setup here. And here we go. Now look at this. The front just barely gets into California here come Wednesday night, but of more interest here, 55-knot winds, nice, strong, solid storm here, moving towards the date line, and then falling southeast some at the same time. Look at this front approaching California on Thursday and moves in on Thursday. This storm continues, and a new, much larger one starts setting up over Japan on Thursday. This system continues to fall to the southeast on Friday, just north of Hawaii, and then into the Gulf of Alaska. So that's definitely looks like a swell producer for both Hawaii and the U.S. West Coast. And then look at this. We have solid fetch all going from west to east. Now, some of it's not particularly strong, but from Japan, pretty much to Oregon. This is a good start. This is classic El Nino here, by the way. We continue on. We're into Saturday. Look at this. You almost have 30-knot winds in pockets the whole way across the Pacific. That's pretty solid and impressive. And look at this. Now it's all started at multiple centers, what they call a complex gale here, with multiple centers, but basically a giant area of low pressure that extends from just off Japan to just off Oregon. Most impressive indeed as of Sunday, if one is to believe the models, and that goes on into almost Monday. So this is a very energetic looking pattern. Now, not super strong, but solid, certainly compared to what we've had. And the other part here is it's moving further to the south. That's good. That provides some exposure now for Southern California, more westerly direction for California, and certainly more energy aimed at Hawaii. This is looking good. Let's go see how these winds are to affect the ocean surface. So here we are, significant wave heights. This is a chart that shows the highest 1/3 of seas across the North Pacific Ocean, and typically what is used to help build swell and surf forecasts. Anyway, here we go. The current gale south of, or in the northern dateline region, but south of that actually here, with seas in the 31-foot range, winds about 40 knots out of the west, certainly generating swell for Hawaii, but you notice most of the vectors here are aimed at the U.S. West Coast. Roll that out, and that continues into Monday, moving into the Gulf, and we saw that on the wind charts too. It kind of peters out, but still you have a huge area of 22 to 24-foot seas here, and that just continues into Wednesday. Now it's more like 22-foot seas, and our next system starts forming off Kamchatka come Wednesday with 34-foot seas. Energy still here. So this is like, probably a 17-second period swell when it's back here, and now in the 13-second range as it moves towards the U.S. West Coast. A lot of energy pushing towards the U.S. West Coast, and certainly Hawaii too, but a little bit more indirect. And then we get into Wednesday night. What is that? A little tiny area of 43-foot seas and 56-knot winds, and then goes to 45-foot seas and about 46-foot seas on 12Z on Thursday morning. Targeting, notice the swell vectors here, targeting Hawaii well, if one is to believe the models, and then 44-foot seas, and then it starts fading out. Oh, actually, so we got one frame from an older run of the models stuck in there. Sometimes it does that. I'm not quite sure why. Anyway, come 18Z Wednesday. Oh, nothing to sneeze at. It's still a little spot of 40-foot seas here, and what is that? So it's every 10 degrees north, that's 600 nautical miles, so there's 10, about 1,100 nautical miles northwest of Hawaii, still 40-foot seas, and also aimed at the U.S. West Coast. And that just barrels right on into the Gulf of Alaska, still with 30-foot seas. Very nice setup, and you can actually see this. Watch this here. Watch this. These are just raw seas. This is not swell, but you can actually just see the seas pushing into Hawaii there and into the U.S. West Coast as well. So someone's going to have to make their choice. Do I go to Hawaii or do I go up north? Either way, plenty of swell if one is to believe the models. And then here comes the next one on Sunday. Not as big, but well to the south. And there we are, 180 hours out. This certainly looks like a nice pulse for Hawaii and certainly for the U.S. West Coast as well. So That looks good. You can't ask for a better situation, really, in terms of swell generation, especially seeing how what we've been through for the past 4 years. This is much more positive, much more encouraging. Let's go take a look at some longer-term data now. And of course, the major influencer on weather for this winter will be El Nino 2015. Actually, we should slash that 2015, 2016. But certainly, El Nino is in play. So we'll play this out as we always do, looking at basically 4 major areas. We're looking for winds in the Kelvin Wave generation area. That's on the equator, 5 degrees north or south of the equator, from about 165, 170 west out to about 135. So you can draw a box right there. And as looking at this chart, as you can see, there is some westerly winds, nothing too much. But remember, this time of year, normally you have trades blowing out of the east at a good clip. And we don't have that. We have calm winds. The net result is here are our anomalies, differences in normal for this time of year. Clear west anomaly pattern back in play, and even more interesting, it's to the south of the equator. Normally all this year it's been on the equator and a little bit north of there. Now it's to the south. Not that this is any particularly different, west anomalies, but still. So what we normally are looking for is west anomalies that in a normal year, that would tell us the active phase of the MJO is in play. But in this sort of a year, you can also get, if you have a prolonged bout of westerly anomalies, that helps create what's called a Kelvin wave. That is taking warm water that's normally here in the West Pacific, transporting it to the east in the form, it actually pushes warm water to depth, and it travels in sort of like a blob or a pocket under the equator, 200 meters under the equator, makes it the whole way across the Pacific, gurgles up off the Galapagos, forms a warm pool, and then that warm pool gets caught by the trades, and as you can see, this is a temperature picture here, right here, and creates a big warm pool of water. That in turn affects the jet stream, brings it south, energizes it, and then creates exactly what you saw on the previous slides, a lot of swell production. Okay, so typically you get these westerly anomalies during the active phase of the Madden-Julian oscillation. It lasts for a couple of weeks and then it's all but done. But guess what? This year, we've had nothing but westerly anomalies since January or so, and it has been nonstop. We've actually just come out of a little period where the inactive phase of the MJO, and let's talk about this for just a second. Normally, during strong El Ninos, the MJO disappears. This 3-week on, 3-week off oscillation disappears, but it has shown its face at times during this El Nino, a little bit of a head scratcher. So we had the inactive phase of the MJO. It destructively interferes with what they call the El Nino base state. The El Nino base state is a propensity for just continued west anomalies. That was muted from about Halloween till about a week ago, and all of a sudden these westerly anomalies started developing. That's very good. That means the inactive phase of the MJO is fading out, we believe, and so El Nino is beginning to express itself more in the atmosphere. That in turn affects the jet stream, and you get exactly the pattern that we saw just in the previous slides. So that's the tutorial for the evening. Let's dig deeper. So we're talking about westerly anomalies. This is the first part of the 4-part series we're talking about. So here's a look back from November 23rd. And again, the Kelvin Wave generation area, really the main area we're looking at is from about 170. So you draw a box out to about 130, so right here. And you see westerly anomalies, but they're displaced off to the east. And the same pattern kind of goes until the 26th of November. And then look at this. Westerly anomalies start building on the date line and then continue as well, and building off to the west. This is what makes us think that the inactive phase of the MJO is fading out. But there's also some tropical activity going on here. But that's typically what happens when the active phase of the MJ moves in. You start getting these tropical influences, especially around the Tahiti area. That starts driving the Southern Oscillation Index negative, which we've seen some of that, and we'll get into that in a minute. And it starts enhancing the jet stream, which we're seeing now. So all these are very positive signs. So next we'll take a look at what the forecast is. Now these are not anomalies, these are actual winds, and here's the Kelvin Wave generation area, at least most of it. There's some that goes off to the east here. The date line's right here. The far western side of it, about 135, is right over here. But you can see, here's the current image as of 18Z Sunday, and we see westerly winds. And those are at 13 knots. Not easterly winds, which would be normal, but actual westerly winds, not anomalies, real westerly winds. A little pocket here pushing up to nearly 20 knots. Let's just sort of take a look here at the forecast for the next week. So those westerly winds sort of fade out, and even if you had calm winds here, that would still express itself as westerly anomalies. But see, we have some westerly anomalies there and still there, much lighter than what we have right now. This is as of Wednesday. Then we'll roll this out and see what happens. Another bit of little pockets of westerly winds, nothing too strong until we get into maybe Saturday, and then it seems that pattern builds a little bit. But also notice we have a lot of trades up in here, but outside of the Kelvin wave generation area, a little bit right here, but nothing, too particularly interesting. And then we'll just roll this out and see where this goes. And that is it about 180 hours out. So probably we're at the peak of the westerly anomalies right now, but still quite solid, quite nice pattern here in the Kelvin wave generation area. And here's another way to look at it. The Kelvin wave, so this is time, October 30th, and remember we said this is where the westerly anomalies died out, and you can pretty much see it here. The Kelvin wave generation area, you just draw a line pretty much down there to somewhere over and about here. The reds are westerly anomalies, the blues are easterly anomalies, and here's where the inactive phase came in early November, kind of put a damper on the jet stream, and then slowly but surely as we get deeper into November, and here we go, here's like 150, so but right in about here is the Kelvin wave generation area, and you can see this bout of westerly anomalies building, not particularly strong, and slowly easing off to the west. And here's just the latest week here, the forecast for the week, and pretty much consistent with what we saw in the previous chart. Pockets of westerly winds, certainly westerly anomalies. Now the deal here is we're not looking for any more Kelvin waves to be generated. If that happened, that'd be great. We'd be all excited. There's piles of warm water in play, enough to do whatever it's going to do for this El Nino cycle. But what we're really looking for westerly winds now is just about being like the active phase of the MJO and positively enhancing the El Nino base state, or at least allowing it to express itself fully, but also allowing the jet stream to roar and produce storms, because that's really, from a surfing perspective, that's what we're interested in, especially big wave surfing. And that appears to be the case, at least for the next week. Now here's the longer term view. Very similar chart to the last one, but flipped over. The current, or the past, is down here at the bottom, and it goes to the current. And this is the CFS version 2 model. And then the forecast out the better part of, 3 months? Okay, yellows and reds are westerly anomalies. We can clearly see here there was a big, what we call a westerly wind burst. When you see red here, that's not just anomalies, that's actual westerly winds down at the surface. About a run from late September into almost a month-long run of westerly winds. That created Kelvin wave number 4, which is erupting in the off the Galapagos right now. And then starting about early November, things started dying out here. Westerly winds backed off. Now here's what's really cool, is starting now, westerly anomalies are to continue, and almost a westerly wind burst here is forecast in the December timeframe. Again, this is not about Kelvin wave generation. If we got a Kelvin wave out of it, great, but we're not so much interested in that. What we're really interested in, again, is enhancement to the jet stream, enhancement to the El Nino base state. And now if one really wants to stretch their imagination, here in February, another westerly wind burst is forecast. But the other part here is you'd have to draw a line from about, let's say, 170, 165, and these westerly winds are there, but at some point the core of this westerly wind machine should start working itself off to the east, outside of the Kelvin wave generation area, and that's a clear signal that El Nino is starting to not only peak out, but also fade as well. Now, the models don't show it, but we believe that at some point here in the January timeframe, you're going to start seeing these westerly winds moving off to the east. Anyway, so westerly winds, what caused them? Okay, well, let's first overlay MJO. Like we said, active phase of the MJO back in October created a westerly wind burst. It was also interacting with with a Rossby wave. And then we go to the inactive phase of the MJO. Westerly winds backed off, and as you can see now, we're just about over that. Active phase supposed to come back in. At the height of the active phase, westerly winds, westerly anomalies, almost a westerly wind burst, as would be expected. A little bit of a slack off period here in January, and that's not untypical. Typically, January, you get some sort of inactive phase, high pressure sets up. Then you get into February, and things start roaring again. I'll lay on top of this Rossby waves. Now you can see the interaction of the MJO and Rossby waves, like there and almost there, create stronger than normal westerly anomalies. Now that is not so much the case here, and not at all the case here. So hard to say, but again, who's going to believe a model 3 months out into the future? Also, the low-pass filter here. So this is the filter that attempts to identify El Nino and the peak of El Nino. And there's this one little dot here we're saying that's the peak of El Nino, at least in terms of westerly wind production. That probably was. But you know what? Look at this. Basically, nothing is supposed to change a whole lot into February, which means we are supposed to be in a very solid El Nino state, and of course, there's nothing to say that we wouldn't be at this point in time. All the data suggests this is completely realistic. So that's the long-term projection wind-wise. Let's go look at the effects of those winds subsurface in terms of moving warm water around. But right before we do that, one other quick look at charts here. Mjo Forecast. So this is the statistic model. The blues are basically the active phase of the MJO, less sunlight reflection off the ocean surface. That's outgoing long-range radiation. Okay, the reds and yellows are more sunlight reflection off the ocean surface. This suggests the inactive phase of the MJO. This suggests the active phase of the MJO. This is probably a pretty good representation at the moment. So per the statistic model, what we really want to see is this active phase die out here. We don't expect at all that it's going to do like this model says and actually work its way into the West Pacific. And if anything, we want to see this inactive phase fade out completely. 2 weeks out, it's supposed to still be in play. Per this model, and this is a little bit interesting here, this is the dynamic model. It had showed originally that the inactive phase was supposed to be dead a week out. Now it has it kind of hanging on and slowly fading, and the active phase slowly fading out with it. So that's not as encouraging as the previous models we saw. Here's yet another view. So this is the phase diagrams. And they're kind of hard to look at, but basically you're looking down at a cross-section of the Earth, Indian Ocean, maritime continent to the West Pacific, across America, into Africa, Western Hemi, and back around. And this tracks the MJO, the active phase of the MJO as it works. If you actually saw a normal MJO, you could see it actually work its way the whole way around the planet, which it does, and see it as it moves to the center, that's weaker. As it moves out, it's stronger. Right now, we have some sort of a moderate active MJO. The forecast has in the next couple of days it just crashing and disintegrating. That's per both these models here, the GEFS, which is GFS Ensemble, and the ECMF. Per this, contrary to those previous models, the MJO is supposed to die completely, and that's exactly what we've been seeing in all the other data. All right, now subsurface temperature profiles. So we've talked about westerly winds, the MJO, and the MJO's effect on westerly winds, or easterly winds for that matter. So this chart, West Pacific here, East Pacific here, going down to depth. These little X's represent sensors on buoys that are strung the whole way across the equatorial Pacific. 2 degrees south of the equator to 2 degrees north is an array of buoys. But you notice also there's a big hole here. A bunch of the sensors are dead on those buoys, but they managed to get at least a bit of the sensors working here lower down. Anyway, so the point being, actual water temperatures, 30 degrees centigrade water temperatures. Pushing to the east, normally all this is balled up way over here. A lot of warm water moving east. Classic sign of El Nino, 28-degree isotherm right here on the 120 line. We'd like to see it move further east, but it has not done that. This suggests some sort of westward displacement of this El Nino. We suspect that might be changing in the near future. Anyway, these are actual water temperatures It is the differences from normal, the anomalies that really matter. Okay, notice all these sensors are out over here. Where is that? That's about right around the Galapagos here. But you can see warmer than normal water. So normally, remember, all this should be way over here, and this cold stuff should be up in here. So a total reverse of the temperature pattern, classic El Nino again, and we've been watching this for weeks. 2-degree anomalies to the date line, 3 degrees, what is that, to about 160 there. The point being really here, 7-degree anomalies right here. We call this the reservoir. It isn't even a single Kelvin wave. It's the result of multiple Kelvin waves and continued westerly anomalies taking whatever warmer than normal water is here and continuing to push it to the east. But the reality is, look at this, there isn't a whole lot of warm water left. Probably the El Nino cycle, at least in terms of warm water transport, is going to collapse somewhere in the next month or so, but that's pretty typical, normal El Nino. Anyway, massive warm water reservoir here and erupting at the surface is typical El Nino. Here's another way to look at it. This is a much better view right here. Okay, so you can see, and this is a little bit, it's all kind of modeled data, but you can see clearly this massive pool of 6, we've seen 7, maybe even 8-degree anomalies right in here. Large pool. We have seen some hints that it's starting to move to the east now. And that's also because, one, there's not a whole lot of warm water to force down in here, though there is a lot of warm water still moving this way. Other part to notice here, it's starting to work its way into, so this is where, that's about 80. This is the Ecuador coast. This pocket has not made it that far to the east in months. Now it's starting to make a push to the east. We think the whole pool is starting to move to the east. Other point here, look at this. This is what, 4 to 5 degree anomalies right here between, what is that, about 110 to about 125 or so, erupting on the surface. So west winds, we talked about that. We're talking about subsurface warm pool, but also notice that the warm pool at some point erupts around either the Galapagos, Ecuador, or even west of the Galapagos. We've been saying this is a westward displaced El Nino, and again, this sort of suggests the eruption point or the eruption ports are west of the Galapagos, so there is warm water working its way in that way. Another way to see what's going on subsurface, this from the Jason 2 satellite. We have Mexico here, U.S. West Coast, South America here, Ecuador right here, Galapagos right there. Okay, so these are not water temperatures. These are strip out the ocean height difference from normal for this time of year. That is, strip out all the waves, strip out the tides, strip out any gravitational forces, and just is there any bulges in the ocean surface? Because what that means is if the ocean is bulging upwards, that suggests you have warm water at depth. At depth, warm water expands. That pushes surface water up a little bit, 20 centimeters. Also notice cooler than water, normal water out here. Completely expected given that basically this area has been drained and normally this warm water would be over here. The cool water would be right here. The pattern is reversed. Again, classic El Nino. Anyway, so the point being here, 20 degree centimeters, very high above normal, suggesting much warm water at depth. This coverage has actually shrunk a little bit in the past 5 days. Not unexpected, given that the warm reservoir below is starting to discharge rather vigorously at the surface and creating a large slick of warm water here, and we'll get into that. Anyway, this is just confirming what we've seen in the previous slides. And then our favorite chart, upper ocean heat anomalies, okay? And basically you can see Kelvin waves, that is warm water, being developed and then pushing off to the east, making it to Ecuador and erupting there. So 1 Kelvin wave back December last year. The first, actually that was the failed El Nino of 2014. Then between Kelvin waves, typically you get this little eruption of cooler water. And then, here we go again. We got into 2015, the spring, 1 Kelvin wave. 2 Kelvin waves, massive westerly wind bursts in the June-July timeframe, 3 Kelvin wave. Now, and we've talked about this before, the width of the 2.5 degree anomalies here, you got to read it across this way, 10, 20, 5 degrees, and anywhere down here you go, it's 25-degree width. Okay, and we were very impressed by that Kelvin wave. Kelvin wave number 3, just wow, that's an impressive thing. And then we got to Kelvin wave number 4, massive westerly winds in the October time frame, off the chart. And if you go and measure this guy, 10, 20, 30, 40, and even today, from 32 to about 95, so it's 38 degrees wide, but basically 2,400 nautical miles of warm water at depth, confirming all the other stuff that we saw before. So, and this is probably the last Kelvin wave. I mean, I can't imagine there'd be any more. And you can already see here this, this is the inactive, the upwelling phase of the Kelvin wave cycle. Up here, it was real prominent and pronounced, less pronounced here, but now you can see a massive upwelling phase getting ready to take place. Now, it'll be months before that upwelling actually manifests itself off the Galapagos, but sort of the end of the warming is in sight. We don't really expect another massive westerly wind burst to occur and create yet a 5th Kelvin wave. And at this point, it really doesn't matter. There's months of warm water here. All right, so we've talked about westerly winds or westerly anomalies in this area. We've talked about Kelvin waves being generated by those westerly anomalies, and those Kelvin waves erupting here around the Galapagos. And then finally, we talk about the warm water that erupts at the surface and its impact. Here's our current situation. Lots of warm water. Looks very good. We're not going to dig too deep into this, the low-res imagery. We've also read some data that suggests water temperatures from GOES east are not functioning at the moment. GOES west is providing coverage. As long as we have coverage in the Pacific, that's all we were really interested in at the moment. This is a clear El Nino signal, not particularly warm right in here. Most of the warmth is out here. When we talk about westward displacement, we're mainly saying that the bulk of the warmth is from the Galapagos eastward. Now, everyone talks about this is an epic El Nino. Well, does it compare to the 97 El Nino, which is the strongest El Nino on record? So here, we're just going to do this. Boom. There's what the 97 El Nino looked like. Now, let's be clear. It was very much eastward displaced. All the energy was right in about here. Yeah, there was energy going out here, but the date line's out here, and there wasn't almost anything going on there. Our El Nino here has plenty of warmth going out to the date line, and it was almost warmer right here in this area. Let's say from about 140 on. And where's 140? That would be, where's Hawaii? There we go, from about here on. So it's a different type of El Nino, a different flavor. This was a super El Nino. Is this a super El Nino? We don't know. The data will bear that out in the months to come. Still, very solid El Nino. Strongest El Nino other than, so there's two super El Ninos, the 82-83 El Nino and the 97-98 El Nino. This one is vying to be the third one. Will it make it? Unknown. Either way, it's a exceedingly strong El Nino. There is nothing stronger than this other than the 82-83 and the 97-98. All right, so let's go region by region, look at, and this is high-res data, 5-kilometer resolution. The previous chart was 50-kilometer resolution, sort of Stone Age comparison compared to these charts here. Anyway, so we now see 4-degree anomalies here between the Galapagos and Ecuador. This is a good sign. This suggests that some of that westward displacement stuff we were talking about is starting to disappear, and that the focus is turning more to the east. Not unexpected, really. A good sign, though, just the same. Compared to a week ago, notice from there to there, much warmth has built in. This is looking much more solid. Let's go on to the next sector. All right, and then we go from about 95 out to, what is this, 160 west. Very warm. I mean, 2.25 degree anomalies here. And remember, the Nino 3.4 area, the region that they use for measuring El Nino, goes from 120 out to 170, and it goes from 5 degrees south to 5 degrees north. We have almost 2.25 degree anomalies over the entire area, with peaks here at 4 degree anomalies here. And this is, remember the subsurface chart we saw before? Here, this one, and the eruption point right there. You can clearly see that right here with the 4-degree anomalies. So the charts are in sync. Go back a week just to sort of see how things have changed. Different. not really a whole lot different. Maybe a shade cooler, but I don't know. It's sort of 6 of one, half dozen of another. And then the final sector from about 155 out to the date line here. Again, nice warm pattern here, typical. We go back a week. Things have actually backed off a little bit here. Notice it went right, made it 2 1/4 anomalies, made it right out to the date line. Now it's retracted a little bit. Again, the measurement line, though, is at 170 west. That's the end of the Nino 3.4 region. That's the region that NOAA uses to determine the strength of an El Nino. So looking very solid from this picture. Here's the chart that depicts change over the past 7 days. We did it sort of that way. Here's another way to look at it. Much more warming here in the Galapagos region. Little patches of warming here and out here, but nothing particular. It's mainly the focus now, and this is what's making us think that maybe the westward displacement part of this El Nino, that character might start disappearing here slightly as warming happens here. The other thing we want to see is cooling here, and we're not seeing that. For whatever reason, because of the active phase of the MJO being over here, we believe that has, in a negative way, and this whole pattern with the inactive phase of the MJO over in this region has sort of taken away some of the edge off El Nino. Then that might change in the next week or two, but just a little point of interest. Here's the high-res overview image, and again, not showing us anything we haven't seen in the low. Warming here. Much warming here at the main vent port and going out to about 170 west. And then finally, this is sort of the mid-zoom picture of the main Nino 3.4 region. Again, you can see the vent port clearly defined. Also notice this, these 4-degree, 3 and 4-degree anomalies now building much stronger here from Ecuador to the Galapagos. This is still very solid, but let's go back a week. And you see here the westward displacement clear, much warming with clear 5-degree vent ports south of Mexico. And out in this region, things have cooled off a little bit now, but it's starting to move to the east. That's not unexpected. So this was probably the peak of Kelvin Wave number 4 pushing through the westward part. As it continues to ease to the east, it would not be unexpected to see more warming here, and that's exactly what we're seeing. We'll see how this plays out, but the peak of this event we're thinking was right around here, November 20th, 22nd or so. That's pretty much the warmest image we've seen going. You can go through daily and pick through it yourself and see, but pretty impressive indeed. And we can go region by region, get a historical perspective on actual temperatures here. You can see Nino 1.2 has not been going, lately it's working its way up, but it was actually very warm back in October. It was even warmer than that earlier on in the year. It's been sort of all over the place. This is the area right there between the Galapagos and Ecuador. Conversely, Nino 3, which is pretty much from the Galapagos off to the west, has been on it. Look at this. It's been 2 degrees above normal or more since at least September. And now look at this. It's right at 2.986, nearly 3 degrees, and has been in that range since, what is that, about November 18th or so. Very impressive indeed. But the main region that we're concerned with, Nino 3.4, that's the region that NOAA looks at for determining the strength of El Nino. Let's take a look there. And here we go. Today's value, 3.039. That is tying, or very nearly tying, the peak that was set back here on, what is that, about the 18th or 19th or so. Very impressive indeed. I mean, we have temperatures just hovering here at 3 degrees above normal. So the previous chart that we saw had 3-degree anomalies also. During the 97 El Nino, those temperatures were up at 3.6. But for the CDAS, at least CDAS 3.4, that region, these numbers are equivalent or better than the 97 El Nino, and this is the region that really counts, at least in NOAA's eyes. And again, if you look at the trend since somewhere about, let's say the 1st of October, so temperatures have been 2 degrees or better above normal. We're really interested to see what the November, we're almost there, what the November average will be. We're thinking somewhere in the 2.5 or better than that, maybe 2.7 or so, which is very warm. How that compares to 97? We're not going to venture a guess yet because there's some play in how all these numbers are derived, but it's very warm nonetheless. It's at least very strong El Nino category. All right, so we've talked about west winds, we've talked about Kelvin waves and warm water building up under the equator, erupting at the Galapagos. We've talked about that warm water forming like an oil slick or a warm patch of water along the equator in the West Pacific. But all that means nothing if it doesn't do something with the jet stream. So there's a couple of indexes here that can be used to measure the effects of El Nino on the atmosphere. This is the Southern Oscillation Index. Difference in pressure between Darwin, Australia, and Tahiti. Negative numbers, a long run of negative numbers suggests at least the active phase of the MJO. If it's long enough, then it suggests El Nino. Currently, we are finally getting back into negative territory after going through a pretty good run of positive numbers here, attributable to the inactive phase of the MJO. Our 30-day running average is up to almost neutral, 2.99, actually starting to trend down again finally. And the 90-day running average is at minus 13. We want to see this down at about minus 20 or so, and this at minus 18 if you want to be in super El Nino territory. And we were there for a while, but the inactive phase of the MJO, again, basically rained on our parade. We're trying to recover some. In terms of how that affects El Nino, probably not a whole lot because it's all about the warm water now, and that train has left the station and it's well down the track, so we're not so worried about that. So part of the issue has been, here's Australia, Darwin's up here, weak low pressure there. You want to see high pressure here, and then you want to see low pressure Tahiti right around in here. Here is our low pressure pattern, and that's what's driving the negative Southern Oscillation Index right now. Just keep your eyes up in here. We're just watching for more low pressure, and we're trying to see some signs of high pressure over here, but we're not seeing it. And then we get to about a week out. And the good news is the high pressure pattern basically fades here. We're not seeing any, whoops, there we go. And basically, actually, let's do that one more time. So you see all this high pressure here that was sort of ridging into Tahiti. By you get 180 hours out. For the most part, it's gone. So the Southern Oscillation Index, at least for a while, for the next week, should stay pretty well negative. Another way of looking at that is the Spi Index. So it measures the difference in clouds between this region and this region here. You want to see more clouds here, less clouds here. The more that pattern's ingrained, the higher this number would be. We're at 0.84. We're up in the plus 2.4 at one point. But typically this guy peaks out in the summer time frame into the early fall, so it's not unusual to see it die off. So we're not too upset about that not being as strong as we'd like. It leads the Nino 3.4 temps. In the end, the thing that really matters is the Southern Oscillation Index, and not even that so much the Nino 3.4 temps. And here's the latest graphic on the 30-day Southern Oscillation Index, and you can see how back in 2013 we were up here in positive territory. That's like La Nina. In 2014, here's our false start El Nino. Then we got into 2015. You see how the 30-day running average was down at minus 23 at a couple of points here, but now it's done this big run up. But it did that here, and then it returned down to negative numbers. We expect that to happen at some point here in the December-ish time frame. And finally, the chart of Nino 3.4 temps. This is the most conservative ERSST V4 centered. So it takes climatology and sort of applies it. The oceans have been getting consistently warmer over the past decades. So this tries to make old El Ninos, put them in the same scale as current El Ninos so you know where you are. Again, 97 was the peak at 2.32. That was a 1 month running mean. The 82-83 El Nino was at 2.21. Then there was this one in 72-73 that was at 2.0. And then here is ours right now. This was last month's at 1.86. The new numbers should be coming in shortly for November. we're expecting to be up here in somewhere in the 2-degree range. You saw the data we saw before with 3-degree anomalies, but again, that's not completely historically correct in terms of this. And this is, using the most conservative sense of, this is all about, are we a super El Nino or not we are super El Nino? This is all about bragging rights here. This isn't anything about how it affects the atmosphere or what's going to be the effect of this winter. It's just, can we exceed the 72-73 El Nino? But interesting point here. 72-73, 82-83, 97. All these, the strongest El Ninos, and this is going back a very, 50 years back to the 50s. All of them have been in, relatively recent time frame. And then this guy, we think, is going to be up in that range too. It's got to get better than 72. It's got to get up here to what 82 was to be a super El Nino. Not sure if we're going to make it or not. But either way, we're in very rarefied company here. All right, so we've blabbed on a bit, but here's the short of it. Swell production looks very good for the coming week. Multiple swells expected, if one is to believe the models. There's swell in the water right now, and more to come. Make the most of it. Dig in, have some fun, be safe. Long term, the projection looks very good with the inactive phase of the MJO fading out. The active phase supposed to build in, and more westerly anomalies, which should enhance the jet stream, which should continue to enhance the storm track as we work our way into December and early January. So, very positive outlook is in store for us. Enjoy it. Go get some surf. Have a good time. We'll do this next week. Same time, same channel. Thank you.